Hi guys, this is Dennis. Today I'm going to walk you through the process of deploying an highly available, scalable, fault-tolerant and secure 4-tier application, including services such as EC2, S3, RDS, Cloud Front Distribution, Route 53, Certificate Manager, and more other, right? So we started this conversation in our study group, but this day we did not have enough time to complete the solution. That's why I decided to make this small video so that people will just make use of and move on. So, because this video might be extremely long or too long, we will split this video in multiple parts. In the first part of this video, we will focus ourselves on the networking part, meaning that in this first video, we are going to create our VPC, the different subnet, and also configure our different route table in this first part. But before, let's explain a little bit our architecture. So we are going to make use of Route 53 for DNS resolution, meaning that instead to paste the DNS of the load balancer or the IP address of our server in the browser to reach that server, we will place the domain name, a specific domain name, or for our case, we will make use of denis.dev.click, right? So meaning that this Route 53, this service is going to be help us to implement this domain name that you're going to make use to reach our application, right? We also going to make use of Cloud Front Distribution integrated with Certificate Manager. So meaning that we are going to create a certificate and integrate that certificate to our Cloud Front Distribution to secure our website or to encrypt the traffic between the client and the server, right? So, and then we are going to make use of the application load balancer, of two application load balancer, the front end one and the back end one. This front end one is going to receive the traffic and send the traffic to the web server, right? Which is our front end server. And once it receives the traffic, once the front-end server receives the traffic, it's going to process that traffic and send to the application load balancer, the backend application load balancer. And this backend application load balancer is going to send that traffic to the app server, which is our backend server, right? And this backend server is going to communicate with the database. So our application, we will have 8 subnet, 4 public subnet and 4 private subnet, right? In the first tier of our application, we will place our NAT gateway and the bastion. The bastion is going to be, we will use bastion in an event if you want to SSH to our different server, this is the web server, the app server, or even if you want to SSH to our database for database administration, right? This NAT gateway we making will help this server or the app server and the database in the private subnet when they want to go to the internet and grab some security update or patching, right, from the internet. That is why we are going to place this NAT gateway in the public, in the first tier, which is the public tier. And in the second tier, we will host our web server, right? And this second tier is also public. In the third tier, we will host our application server, which is the application logic of our application. And in the fourth tier, which is the database tiers, we will have our database. We will also make use of S3 bucket, right? Why are we going to make use of that S3 bucket? This web server, to be able to talk how does this web server is able to talk to the app server? How does the web server will be able to talk to the app server? There is a file called reverse proxy file. It's a specific file and very important file that this web server need to make use of to be able to send traffic to that application, to that backend application load balancer. Because in that specific file, we have the DNS of this backend application load balancer. That is why every time that this web server wants to talk to the app server, it's going to be making use of that specific file and get into that file, grab the DNS of the backend load balancer to be able to send the traffic to that backend load balancer. And where are we going to store this file? We will store this specific file in the S3 bucket, meaning that if this web server wants to talk to the backend server, or if this web server wants to send the traffic to the backend application load balancer, is going to go in the S3 bucket, grab that specific file, or grab the DNS of the backend load balancer in that specific file, so that we will be able to send the traffic to that load balancer. And also, if the application server will want to talk to database from time to time, right? Maybe to write something in the database or to get something from the database, right? To be able to do that, you need to authenticate to that in that database using database credential. Where are we going to store those credentials? We will store those credentials in the S3 bucket, meaning that if the application server wants to talk to the database, you will go in our S3 bucket and get that those credentials and making use of to be able to talk to the database. And that's basically how our application is going to, how the traffic is going to flow into our application. So, like I say, in this first part of the video, you focus ourselves on creating of spin up or our creating our networking, our network. So we will focus ourselves on networking. We will create the different the VPC and the different subnet, right? Let's move in our console. So that's our console. All we need to do in the VPC, when you click on VPC, you just click on create VPC and select VPC and more. You'll uncheck this because we want to provide our own name to the VPC. But let's scroll down here and explore the different options. For our case, we need 2 availability zones, meaning that we will select 2. Also, for our case, we need 8 subnet, but like you can see, AWS doesn't give us the ability to create 8 subnet at a time. It just gives us the ability to create up to 2 public subnet and up to 4 private subnet, meaning that we cannot create 8 subnet at a time. How are we going to manage that? For the first time, we will create our VPC with 6 subnet, meaning that 4 private subnet and 2 public subnet. But because we need in our architecture, because we need 8 subnet, we will create 2 more public subnet and add to our VPC. So for the first time, we will create our VPC with 6 subnet, 4 private subnet and 2 public subnet. And later on, we will create 2 more public subnet and add to that VPC. But let's understand which subnet are we going to be starting off on. We will start by creating this first tier, meaning that this public subnet, the NAT ALB subnet 1 and NAT ALB subnet 2, and then we will we also associate those 4 private subnet in our VPC, and later on we will come back and create those the web tier or the web subnet and integrate that web subnet to our VPC. So let's move on here. So like I say, we have two availability zone, two public subnet, four private subnet. Let's integrate the NAT gateway because we need the NAT gateway. We need one NAT gateway per availability zone. Let's just integrate that now. We don't need the VPC endpoint. Just click on none. So let's provide the name for our VPC. Let's call that dev VPC, right? And here, that's the first tier. I mean, that's the first subnet, the first public subnet. Let's call that dev NAT ELB subnet 1, right? Let's copy and paste here. Nice subnet 2 easy 2. That's the, let's call this tac. That's the application server app subnet 1 app subnet 2. That's our database. Let's call that DB subnet 1 and DB subnet 2, right? Here is our you need to name our route table. This route table is associated to those first public subnet, and this route table has the route which is pointing to the internet gateway. That's what makes this those subnet public. Let's give the name to that route table. Let's call that dev NAT ELB RT, right? Let's call okay, let's copy and paste here. That's the route table for our application server. Let's call that dev app, copy and paste it. This dev app RT1 means that is the easy one, and dev app RT2 in easy 2. Let's call that dev. That's our the route table of our subnet database. So let's call that DB RT1, and let's copy and paste here. I'll call that 2. Okay. So this is our internet gateway. Let's just call that dev IGW, right? And this is our NAT gateway. And like you can see the connection between the NAT gateway and the route table, meaning that this route table, this application route table, right? This application, dev application, is associated to this subnet, this dev app subnet, and this route table has the route which is pointing to the NAT gateway, meaning that if the server which is located in this specific subnet wants to go to the internet and grab some security or soft patching, right, it will just go through the NAT gateway, because this route table has the route which is pointing to that specific NAT gateway, and you can see the connection, right? Let's call that dev NAT 1 and 2. So we good. Let's check again. Everything is okay. We gave the name of our VPC, the name of our different subnet, and the name for our route table and the networking connection, and we can basically see the different connection between so let's click create VPC. It's going to take some time because it's going to provision the elastic to elastic IP and also the NAT gateway. That's why it's going to take some time. Let's go in our architecture and let's explain again our architecture. Like I say, what we did, we just created our VPC with 6 subnets, the first tier, the third tier, and the fourth tier. We're going to come back and create the second tier. The second tier is the tier which is going to host our web server, and this tier is also public, meaning that we will create 2 more public subnets or 2 more subnets, and then we will create 2 route tables, and in those route tables we will add the route who is pointing to the internet gateway and associate that route table to our different subnet, right? Meaning that we create the subnet and then create the route table, associate that route table to the subnet, and update that route table by adding the route who is pointing to the internet gateway. Let's go and see if our VPC is ready. It's still in the process. And also, don't forget that we will also make use of IAM role. Why are we going to make use of IAM role? We will make use of IAM role because we have said that the web server will want to go in the S3 bucket and grab the DNS of the load balancer, the backend load balancer, in a specific file, which is hosted in our S3 bucket. To be able to talk to that S3 bucket, we need to attach the role to the EC2 instance who is hosting that server, right? That's why we are going to we will make use of IAM role to give that capability to our server to be able to go in the S3 bucket and get that file, right? So our VPC is ready. Let's navigate and create those subnet. We need 2 more subnet public. Click on subnet, click on create subnet, select the VPC, which is our dev VPC. Scroll down, give the name to that subnet. Let's call that dev web subnet 1, right? And then select the easy, which is easy 1. Let's give the decider. Let's give 10.0.2032.0/20 and click create subnet. Sorry. Let's create the second subnet. Let's select the VPC, provide the name. Let's call that dev web subnet 2. Let's select our AZ2. Let's provide the CIDR block 10.0.48.0/20, right? And click create subnet. Okay, good. So now we need to create the route table, right? Let's click on route table, click on create route table. Let's provide the name for our route table. Let's call that dev web RT1. Let's select the VPC and click on create route table. The first thing that we're going to do here is to associate that or to implement the subnet association. So meaning that we want to associate this route table to the subnet that we just created. Click on subnet association, click on edit association, and you will select the dev web subnet 1 because that's the route table. That is a dev web rt1. So let's click on save association. Now we need to update the route, meaning that we need to add the route which is pointing to the internet gateway, because we say that this subnet is a public subnet. So let's click on edit route, click on add route, select the destination which is internet, select the target which is internet gateway, and then click on save association or save changes. So let's navigate to our other route table, which is the dev route, dev web rt2, dev web rt, which is dev web. You have dev app, dev web rt1. Oh, it seems I make mistake. Okay, let's click on this. Okay, yeah, it's right here. No, that is dev app, dev web rt1. I'm looking for dev web rt2, dev web. I'm looking for dev web rt2. That's one. That is a dev app, dev web rt1. Let's click on this one and see if okay, this is updated. Let's go back. Dev web rt1, dev app, dev web. Let's prod. Okay, I can see. Let's just create another one. Dev web rt2. Select the VPC and hit enter and hit create table. Oh yes, maybe we did not create that. So let's just click on edit route table and add the route which is pointing to the internet gateway. Click on save. Now we need to do the subnet association for the subnet 2. Let's click on subnet association and select dev web subnet 2, right? It's this one. So dev web subnet 2 to associate the subnet in the AZ2, right? Click here. So we good. So meaning that now we have our 6 subnet. Let's highlight those 6 subnet. You have the first one. You have that. You have our 8 subnet. So let's just highlight the different subnet that we created. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we created 8 subnet in our VPC, meaning that in this architecture we have created what did we do? We have created our VPC, and then we have created the different subnet in our VPC, 8 subnet, 4 public subnet and 4 private subnet, and we added the NAT gateway in the first tier on the AZ1 and in the AZ2. So we're done with the networking configuration. In the second video, we will create together different security group for a different level, and also we will move on to other services. Thank you.